Alright, so we're back with Java, understanding static. There will be times when you will want to define a class member that will be used independently of any object of that class. Normally, a class member must be accessed only in conjunction with an object of its class. However, it is possible to create a member that can be used by itself without reference to any specific instance. To create such a member, precede its declaration with the keyword static. Whenever, whenever a member is declared static, it can be accessed before any objects of its class are created and without reference to any object. You can declare both methods and variables to the static. Okay. The most common example of a static member is main. Main is declared at static. Main is declared as static because it must be called before any objects exist. Alright. Instance variable declared as static are essentially global variables. When objects of its class are declared, no copy of a static variable is made. Instead, all instances of the class share the same static variable. Methods declared as static have several restrictions. They can they can only directly call other static methods of their class. They can only directly access other static variables of their class. They cannot refer. Okay, methods declared static. They cannot refer to this or super in any way. The keyword super relates to inheritance. Okay. If you need to do computation in order to initialize your static variables, you can declare a static block that gets executed exactly once when the class is first loaded. The following example shows how a class that has a static methods, some very static variables, and a static initialization block. Alright. So we have useStatic, static A, B. Then we create a static block. Okay, so this static block will be executed at the static block initialized. Alright. Static void methods x, a and b. Alright. So as soon okay, so let me write this. This is use static. So example of using static variables methods. Okay, static methods can only access static other static variables, right? Right. They can only directly call other static methods of their class. They can only directly access static variables of their class, and they can only refer to this or super. They cannot refer. Alright. Methods and static initialization block. So we have class use static. We create static int a equals 3, another static variable p. Then we create a static method. Okay. x, right? We have static. Okay, then we create a static block. Alright, so within static block, system.out static block initialized. And then we give b some value, b equals 8 times 4. We have, then we come up to, then okay, then we declare our static. Okay. So we have public static void main. Now we have a main function. And then we call this. Okay. So as soon as the use static class is loaded, all of the static statements are run. First a is set to 3, then the static block executes, which prints a message and initializes b times this. The main is called, which calls meth passes 42 to x. The 3 print line statement refers to two static variables a and b as well as parameter x. Okay. Alright, so let me try and run this. There we go. Okay. Alright. So, okay, outside of the class in which they are defined, static methods and variables can be used independently of any object. To do so, you only need to specify the name of the class followed by the dot operator. For example, if you wish to call a static method from outside of its class, you can do so using the following general form: class name and method. Okay. Here, class name is the name of the class in which the static method is declared. As you can see, this format is similar to that used to call a non-static method through object reference variable. A static variable can be accessed in the same way by the use of the dot operator on the name of the class. A static variable can be accessed in the same way by the use of the dot operator on the name of the class. This is how Java implements a controlled version of global methods and global variables. Here is an example inside main. Okay, so we have static demo, static, right, static by name. So static demo dot call me, and then we try to access same. Okay. Alright. So we have Java static by name, static by name. Sorry. So we get a static demo class. So static demo, then we declare static int equals 40 int b equals 30. Then we have a static method void call me, right, and it just prints a. Okay. And then we have class static by name. Alright, so we will define our main function. Then I can call me, or I can directly access the static variable. You can use static members as class name dot static member. So let's run it. Alright, we have introducing final. A field can be declared as final. Doing so prevents its content from being modified, making it essentially a constant. This means that you must initialize a final field when it is declared. You can do this in one of two ways. First, you can give it a value when it is declared. Second, you can assign it a value within a constructor. The first approach is probably the most common. Okay. So int file new file open 2. Okay. Subsequent parts of a program can now use file open etc. as if they were constants, without fear that the value has been changed. It is a common coding convention to choose all uppercase identifiers for final fields, as this example shows. In addition to fields, both method parameters and local variables can be declared final. Declaring a parameter final prevents it from being changed within method. Declaring a local variable final prevents it from being assigned a value more than once. Okay. So the keyword final can also be applied to methods, but its meaning is substantially different than when it is applied to variables. This additional usage of finals is explained in the next chapter when inheritance is described. Okay. And we have arrays revisited. Arrays were introduced early in this book before classes had been discussed. Now that you know about classes, an important point can be made about arrays. They are implemented as objects. Okay. Because of this, there is a special array attribute. There's a special array attribute that you will want to take advantage of. Specifically, the size of an array. That is, the number of elements that an array can hold is found in its length instance variable. Okay. All arrays have this variable and will always hold the size of the array. Okay. So this is a length of, okay, so we created some arrays here. Okay. As you can see, the size of each array is displayed. Keep in mind that the value of length has nothing to do with the number of elements that are actually in use. It only reflects the number of elements that the array is designed to hold. Okay. You can put length member to good use in many situations. For example, here's an improved version of stack. As you might recall, the earlier version of this class always created a 10 element stack. The following version lets you create stacks of any size. The value of stack length is used to prevent the stack from overflowing. Okay, so we have stack, we provide a size, we have stack length. Stack length -1, stack is full, and same thing. Okay. Notice that the program creates two stacks, one 5 element deep and another 8 elements deep. Yeah. Okay. As you can see, the fact that arrays maintain their own length information makes it easy to create stacks of any size. Alright, so I can I can using the keyword final to create constants class final demo final and say code equals 10. Or you can create class final class So what happened? Identifier expected a legal start of type. A legal start of type. Oh, sorry. Yes, main function. Public, static, void, main, string, args. All right. Okay, great. And also, we had arrays length attribute, right? Yeah. Okay. Okay, so in Java, arrays are also objects and contain a length attribute which corresponds to the length slash capacity of the array. So class array length, here we go, public, static, void, main, string, args. Alright, void, main, string, args, and then I can create int array, say of size 10. Array length is there we go. Okay. Then we come on to introducing nested and inner classes. Okay, it is possible to define a class within another class. Such classes are known as nested classes. The scope of a nested class is bounded by the scope of its enclosing class. Thus, if class B is defined within class A, then B does not exist independently of the scope of a nested class is bounded by the scope of its enclosing class. Okay, B is defined within. Okay, so B does not exist independently. Okay, right. A nested class has access to the members, including private members of the class in which it is nested. However, the enclosing class it does not have access to the members of the nested class. Right. A nested class that is declared directly within its enclosing class scope is a member of its enclosing class. It is also possible to declare a nested class that is local to a block. Okay, so there are two types of nested class: static and non-static. A static a static nested class is one that has static modifier applied. Because it is static, it must access the non-static members of its enclosing class through an object. Okay, because it is static, it must access the non-static members of its enclosing class through an object. That is, it cannot refer to non-static members of its enclosing class directly. Because of this restriction, static nested class are seldom used. Okay, so the most important type of classes, nested class, is the inner class. An inner class is a non-static nested class. It has access to all variables and methods of its outer class and may refer to them directly in the same way that other non-static members of the other classes do. Okay. The following program illustrates how to define and use an inner class. The class named outer has one instance variable outer x, one instance method named test, and defines one inner class called inner. Okay, so we have outer x. Alright, so we have, okay, demonstrate inner class. We have outer class with the variable outer x and a method. Then we create a object of inner class and inner dot display. Right, so this is an inner class. Okay, and it can directly access all the variables of the. Alright, we have class inner demo. Okay. Alright, so in the program, an inner class named inner is defined within the scope of class outer. Therefore, any code in class inner can directly access the variable outer x. An instance method named display is defined inside inner. This method displays outer x on the standard output stream. The main method of the inner class demo creates an instance of outer class and invokes its test method. That method creates an instance of the inner class and displays the method. Display method is called. Okay. It is important to realize that an instance of inner class can be created only in the context of outer. Java compiler generates an error message otherwise. In general, an inner class instance is often created by code within its enclosing scope. Okay. So it is important to realize that an instance of inner can be created only in the context of outer. Okay. As explained, an inner class has access to all of the members of its enclosing class, but the reverse is not true. Members of the inner class are known only within the scope of the inner class and may not be used by the outer class. Okay, so we have inner 10. Alright, test. Here y is declared as an instance variable of inner. Void show y error. Right. Okay. Thus, it is not known outside of that class and it cannot be used by show y. Although we have been focusing on inner classes declared as members, within an outer class scope, it is possible to define inner class within any block scope. For example, you can define a nested class within a block defined by a method, or even within the body of a for loop. Define an inner class within a for loop. Okay. So we have defined. Right. Okay. So, while nested classes are not applicable to all situations, they are particularly helpful when handling events. We will return to this topic of nested class in chapter 24. There you will see how inner classes can be used to simplify the code needed to handle certain types of event. Okay. Okay, you will also learn about anonymous inner classes, which are inner classes that don't have a name. Alright, one point of interest, nested classes were not allowed by the original 1.0 specification for Java. They were added by Java 1.1. Alright, then we have exploring string class. I think I should add a nested class. Okay. So inner class, I should rewrite it to inner class demo. do in a class demo. Alright, so demonstrates an inner class. Okay. So first we'll define a outer class, then provide a variable outer x equals 10. Then we have okay, then I can inner class, right? Then I can create y equals 20, right? Then this, then we can have void display, which can print it out. And, outer x okay. However, okay, then I can create a void test test inner, and I can create an instance variable of inner class. Inner I equals new inner, right? And we can have I dot display, and then system inner y alright, and then we can display this outside. So we will create an object of outer, and then I can call the test inner function. And there we go. It's exploring the string class. Although string class will be examined in depth in part 2 of this book, a short exploration of it is warranted now because we will be using strings in some of the examples programs shown towards the end of part 1. String is probably the most common used class in Java's class library. The obvious reason for this is that strings are a very important part of program. The first thing to understand about strings is that every string you create is actually an object of type string. Even string constants are actually string objects. Okay. String literals. Okay, so this is a string object. Huh. The second thing to understand about strings is that objects of type string are immutable. Once a string object is created, its content cannot be altered. While this may seem like a serious restriction, it is not for two reasons. Okay. Not be altered. If you need to change a string, you can always create a new one that contains the modifications. Java defines peer classes of string called string buffer and string builder, which allows a string to be altered. So all of the normal string manipulation are still available in Java. String buffer and string builder are described in part 2. Okay. String can be constructed in a variety of ways. The easiest is to use a statement like this. Okay. Once you have created a string object, you can use it anywhere that a string is allowed. For example, here. Okay, Java defines the operator for string objects plus. It is used to concatenate two strings. Right. Okay. So result is in my string containing I like Java. Right. Okay, you cannot do that in C++. Okay, the following program demonstrates the preceding concepts. So we have the string object and okay, the output produced by this program is shown here. The string class contains several methods. String class contains several methods that you can use. Here are a few. You can test two strings for equality by using equals. You can obtain the length of a string by calling the length method. You can obtain the characters at a specified index within a single string by calling char at. The general forms of these three methods are here. Okay. So here's the program that demonstrates these methods. So we have string, we define the length, we show the char at, we check equals. Okay. So of course you can have an array of strings just like you can have array of other types of objects. For example, we create this. Alright. Okay, so here's the output for the program. As you will see, the following section, string arrays play an important part in many Java programs. Okay. Then we have using command line arguments. Sometimes you will want to pass information into a program when you run it. This is accomplished by passing command line arguments to main. A command line argument is the information that directly follows the program's name on the command line when it is executed. To access the command line arguments inside the Java program is quite easy. They are stored as strings in a string array passed to the args parameter of main. The first command line argument is stored at arg0, the second arg, and so on. Okay. For example, the following program displays all of the command line arguments. Okay. That it is called with. Alright. So we have this is a test 100 minus 1. Okay. Remember, all command line arguments are passed as strings. You must convert numeric values to the internal forms manually. Then we have var variable length arguments. Okay. I feel like I should do the string and command line arguments. Okay, right. So I can do strings string class demo demonstrates command line args using string class feature. Okay, so we will go with public static void main. Alright, so we'll go with, you can use length equals and char at methods for string class. Okay, so even uh, string literals are string objects. String literals are string objects, and what? String literal or string objects. Okay. So we'll go with for int I equals 0, I less than args dot length I plus plus um, system dot out dot print line say arg you can go args of I dot char at 0. Right, okay. So we have Java, one, two, three. Okay. Oh, args dot length. Oh, okay. So my bad. Args is an array. Right. Yeah, OTT. OTT. Alright. Okay, variable length arguments. Beginning with JDK5, Java has included a feature that simplifies the creation of methods that need to take a variable number of arguments. This feature is called varargs and it is short for variable length arguments. A method that takes a variable number of arguments is called a variability method or simply a vararg method. Situations that require that a variable number of arguments be passed to a method are not unusual. For example, a method that opens an internet connection might take a username, password, file name, protocol, and so on. But supply defaults if some of this information is not provided. In this situation, it would be convenient to pass only the arguments to which the defaults did not apply. Another example is the printf method that is part of Java's I/O library. As you will see in chapter, it takes a variable number of arguments which it formats and then outputs. Okay. So we have prior to JDK5, variable length arguments could be handled two ways, neither of which was particularly pleasing. Okay, first, if the maximum number of arguments was small and known, then you could create overloaded versions of the method, one for each way the method could be called. Although this works and is suitable for some cases, it applies only a narrow class of situations. In cases where the maximum number of potential arguments was larger or unknowable, a second approach was used in which the arguments were put into an array and then the array was passed to the method. Okay. This approach, which you may still find in older legacy code, is illustrated by the following program. Okay. So you have pass array, right? Alright, so we have this. test. Okay. Static method. Class pass array. Okay. The output is this. So, in the program, the method va_test is passed with the argument through the array v. This old style approach to variable length argument does enable va_test to take an arbitrary number of arguments. However, it requires that these arguments be manually packaged into an array prior to calling va_test. Not only is it tedious to construct an array each time va_test is called, it is potentially error prone. The var_args feature offers a simpler, better option. A variable length argument is specified by 3 periods. For example, here's how va_test is written using var_arg. Okay, so we have integer and v. Okay, this syntax tells the compiler that va_test can be initialized with 0 or more arguments. As a result, v is implicitly declared as an array. Okay, v is implicitly declared as an array of type int. Okay, this inside va_test v is accessed using the normal array syntax. Okay, that is great. Okay, the output from the program is the same as the original version, and there are two important things to notice about this program. First, as explained inside va_test, v is operated on as an array. This is because v is an array. The syntax simply tells the compiler that a variable number of arguments will be used and that these arguments will be stored in an array referred to by v. Okay. Second, in main, va_test is called with different number of arguments, including no argument at all. The arguments are automatically put in an array and passed to v. In the case of no arguments, the length of array is 0. Okay. A method can have normal parameters along with a variable length parameter. However, the variable length parameter must be the last parameter declared by the method. Okay. Alright, and in this case, the first 3 arguments in a call do it are matched to the first 3 parameters. Then any remaining arguments are assumed to belong to val. Okay. Remember, the var_arg parameter must be the last. For example, the following declaration is incorrect. Okay. Here there is an attempt to declare a regular parameter after the var_arg parameter, which is illegal. There is one more restriction to be aware of. There must be only one arg parameter. Okay. The attempt to declare the second var_arg parameter is illegal. It's a reworked version of va_test method that takes a regular argument and a variable length argument. Okay. So we have string message and then okay. Okay, overloading var_args methods. Okay. I think that is local variance instance. The reference types. Okay. You can overload a method that takes a variable length argument. For example, the following program overloads va_test 3 times. Okay, so we have va_test with int v, we have va_test with boolean v, and then we have a va_test with string and okay. Installer static. Okay, so we have testing 1 2 3. Right, so this program illustrates both ways that a var_arg method can be overloaded. First, the type of its var_arg parameter can differ. This is the case for va_test int and va_test boolean. Remember, the 3 periods cause the parameter to be treated as an array of the specified type. Therefore, just as you can overload methods by using different types of array parameters, you can overload var args by using different types of var args. In this case, Java uses the type difference to determine which overloaded method to call. Okay. The second way to overload a var arg method is to add one or more normal parameter. This is what is done with VATest string int. In this case, Java uses both the number of arguments and the type of arguments to determine which method to call. Okay. Then we have a var arg method can also be overloaded by non var arg method. For example, VATest int is a valid overload for VATest in the foregoing program. Okay, this version is invoked only when one int argument is passed. When two or more arguments are passed, the var arg version is used. Okay. Then we varargs, and ambiguity. Somewhat unexpected errors can result when overloading a method that takes a variable as argument. These errors involve ambiguity because it is possible to create an ambiguous call to an overloaded varargs function. Vararg method. Okay. So we have varargs 4, we have VATest boolean, right? Error, right. Okay, in this program the overloading of VATest is perfectly correct. However, this program will not compile because of the following call. Because the var method can be empty, this call would be translated into a call to VATest. Okay, both are equally valid, thus the call is inherently ambiguous. Here's another example of ambiguity. Okay, right. The following overloaded version are inherently ambiguous even though it takes normal parameters int. Okay, although the normal list of VATests differ, there is no way for the compiler to resolve the following call. Right. Then we have, does this translate into a call VATest int with one argument or VATest int with no var arg argument? There's no way for the compiler to answer this question. Thus the situation is ambiguous. Right. Because of ambiguity, errors like those just shown, sometimes you will need to forego overloading and simply use two different method names. Also, in some cases, ambiguity errors expose a conceptual flaw in your code, which you can remedy by more carefully crafting a solution. Local variable type inference with reference types. As we saw in chapter 3 beginning with JDK 10, Java supports local variable type inference. Recall that when using local variable type inference, the type of the variable is specified as var, and the variable must be initialized. Earlier examples have shown type inference with primitive types, but it can also be used with reference types. Okay. In fact, type inference with reference types constitutes a primary use. Okay, so we declare, here is a simple example that declares a string variable called maestro. Okay. Because a quoted string is used as an initializer, the type string is inferred, right? Okay. As explained in chapter 3, one of the benefits of local variable type inference is its ability to streamline code, and it is with reference types where such streamlining. Okay. So as explained in chapter 3, one of the benefits of local type inference is its ability to streamline code. Okay, so as explained in chapter 3, one of the benefits of local variable type inference is its ability to streamline code, and it is with the reference types where such streamlining is most apparent. The reason for this is that many class types in Java have rather long names. For example, in chapter 13 you will learn about file input stream class, which is used to open a file or input operations. Okay. In the past, you would declare declare and initialize a file input stream using a traditional declaration like the one shown here. Okay, with where you can just do this. If fin is inferred to be of type file input stream because that is the type of its initializer. There is no need to explicitly repeat the type name. As a result, this declaration of fin is substantially shorter than writing it the traditional way. Thus, the use of var streamlines the declaration. This benefit becomes even more apparent in more complex declarations, such as those involving generics. Okay, in general, streamlining attribute of local variable local variable type inference helps lessen the tedium of entering long type names into your program. Okay. Of course, the streamlining aspect of variable type inference must be used carefully to avoid reducing the readability of a program and thus obscuring its meaning. For example, considering a declaration such as the one shown here. In this case, it may be not immediately clear to someone reading your code what the type of X is. In essence, local variable type inference is a feature that you should use wisely. Okay. As you would expect, you can also use local variable type inference with user-defined classes. As the following program illustrates, it creates a class called myClass and then uses local variable type inference to declare and initialize an object of that class. Okay, so where? Okay, right. Okay. So here the type MC will be inferred as myClass because that is the type of the initializer, which is the new object. Okay. So as explained earlier in this book, for the benefit of readers working in Java environments that do not support local variable type inference, it will not be used by most examples in the remainder of this edition of the book. This way, the majority of examples will compile and run for the largest number of readers. Okay, so I am done.